All right, so let's finish this off. As I mentioned before,
Article
you
function.
should always watch these videos. They really explain it, and it's good to also get another perspective on how to graph and stuff other than my own, especially because this does go over how we kind of know how these functions are supposed to go and how to kind of smooth these things out. And I like how they have the little cartoons. All right, so let's get into graphing. So the way you want to graph is you plug it in and you solve each value. So notice how we're plugging in perfect roots here. The reason why we're doing that is because if we take the square root, um, it'll make it easier to multiply. So we're starting off with really big numbers here. That way we can see our graph going. If we would have started with smaller numbers, it would have been hard to do because we would have been like, oh, this little tiny number here. But the bigger numbers we plug in, uh, the easier it is to scale this. If we did too big, though, our scale would be a little too large. So that's why they kind of did this, that we can kind of get that little curve going. Too big also would make it look more like a line than a curve. So you do want to have small numbers in there. All right. And they're literally just graphing it off that chart from right here. All right. So let's do a graph. So if we're doing this graph, we want to make sure that what we divide, what we plug in for v after dividing by 2 is going to be a cubic. So for example, cubic functions would be like 1. So we're not going to plug in 1. We would actually plug in 1 times 2. So we would plug in 2 because we're going to divide it by 2 and then take the cubic root, which would be 1. Another cubic function would be 8. This is 2 times 2 times 2. But we're not going to plug in 2. We would plug in 16. That's because 16 divided by 2, it didn't look like a 16. 16 divided by 2 would be 8. Then we can take the cubic root. They were smart. They did 0. 0 is technically a cubic root, I guess you can say. 0 times 0 times 0. If we multiply that by 2, it's still 0. So these are the numbers we're going to start plugging in. And you can see here that Edmentum took it another step, and they also did the negative versions of these numbers. They did 0, 2, and 16. They also did the negative version because you can take the cube root of a negative. You can't take the cube root of an you can't take the square root of a negative number. And then here we can start graphing it. So now that we've had some functions, we can start graphing them. So you always kind of want to think, you want to make the inside, it's going to be squareable for this one. So in this case, they gave us our numbers. So the square root of 0 is 0. For this one, what we're going to want to do is we're going to want to divide it by 2 first. So let me grab my calculator. We're going to do 3,872, divide that by 2. I really hate this calculator because it wants the number first, then you square root it, because normally I would have to do square root answer. But I guess in this case it works out because now I just have to hit the square root button, and I'm going to get 44. The next one, well, give me a second here. So that's uh, so this is going to be, if we divide it by 2, well, that's easy. 50 divided by 2 is 25. So we're doing 2,500 square root it 50. So this, you can notice, even though they're big numbers, they're really good on the square root end. Um, this one, I feel like these numbers they probably thought it out ahead of time somehow. I'm not sure why they're so high, but it works. So 60, 50 square rooted, oh, divided by 2, sorry. Divide this by 2, And then we're going to square root that number, and we get 55. And then we're going to take 64, 28, so 64, 98, I'm sorry, 64, 98. Divide that by 2. We're going to square root that number, and we get 57. All right, so there we go. You can see the answers there. Pretty simple, just plugging into calculator and figuring it out. What is the reasonable domain in the context of the problem? Well, the domain is all the x values. So we would have to say anything bigger than 0 for sure, but it wants reasonable. So let's take a look here. Community basketball court. The length of the court is twice the width. Modeled, what is the area? So in this case, reasonable would probably be somewhere greater than 30 feet, I would say. Because 0 feet, it's like, well, what if you have a 1 foot basketball court? Not going to work. With less than 200, I mean, yeah, but again, that can also be 1 foot. With less than 60, I mean, yes, but again, you can still have that one. Greater than 30, yes, but what if we get up to 200? So I think right here in the middle is a good kind of like, that's reasonable for a basketball court. All right. And the key word there was reasonable. So yes, obviously it's okay to have 30 over 0, but let's talk about this one. So the graph of this, well, it's a square root. So we know it's like this, but at 700 output, we're not going to get only 5 feet. So it's definitely not that. Let's kind of look at our chart here. If our input is, oh, actually, it might be. What I would do is I would look at this 5,000 and see that it's 50. So I would want to find one where 5,000 is present and we get 50. So it could be this, but probably not that helpful. 5,000 would be about here. That looks good. Let's see if something else. 5,000, well, that's not helpful at all. And it's not accurate because we're not even at 50 and this thing's over 50. So it's definitely not this one. 5,000 would be over here. And again, it's over 50. So the only reasonable one I see here, and this one as well wouldn't work because if it's 5,000, we should be a lot closer to 50 than that, is this one. And again, that came from me looking at one that's easy to spot. I thought 5,000 would definitely be marked. They decided not to mark 5,000, I guess, to make it a little more challenging. So 5,000 is right around here, and it's right around 50. All right, so, and we got it right. All right, so let's look at question 2. All right, so this one, pretty simple what we're doing here. Again, we're just plugging stuff in. So what I'm going to do here is I'm going to actually plug all of this into Desmos because something like this is very long. We want to kind of have enough room for it. So I'm going to go to Desmos, go to my scientific calculator, and I want to start this off with a cube root. So I'm going to push this nth root button. I'm going to make my n3, and then I'm going to plug everything inside here. So that's going to be 2. And then our input, we don't know what our input is yet. Oops. No, I accidentally hit enter. So it's going to be 2, whatever my input is. All of this I want divided by, what am I dividing by? 5. And on the outside, make sure we're out of that root plus 1. Now what I can do is I can just plug in whatever I want here. So my first one would be negative 160. And I get -3. So I can just plug in -3. Notice how I didn't hit enter. There's a reason for that, and I'll show you right now. Because if I hit enter, it's gonna create a brand new problem. I don't want that because I just want to plug in my next one. So I want to plug in negative 20. So I'm going to erase this 16, plug in a 2. That saves me that 0 there. All right, and this is going to give me negative 1. I'm going to plug in negative 1. If I plug in 0, I would hope you guys can solve this without a calculator. 0, the cube root of 0 is 0, because 2 times 0, blah. It's all 0. But then we have this plus 1. So this should be 1. All right. The next one we're going to do is positive 20. Ideally, if this is truly symmetrical, this should be the same. But the reason why it isn't is because of that plus 1. That plus 1 is kind of raising everything up. So this technically would have been a negative 2, but that plus 1 raised it up. This would have been a 2 as well, but that plus 1 raised it up. So if this is supposed to be a negative 2, then this should be a positive 2. But again, we're talking about that plus 1 raising it up. So this should be a 4. Let's see if I'm correct on that. 160. Did I do something wrong here? This should be a negative 4, meaning this is a positive 4, but the plus 1 raised it up. Oh my gosh. I forget this plus 1 is acting a little bit backwards on this. The absolute value went down, but the number overall went up. So this should have been a negative 4, which means this should have been a positive 4. Whoops. Well, it's a good thing we checked that. This I know for a fact is going to be 1 because of just how 0 interacts with everything. The other one was just me trying to, I guess, meta game this. All right. And I failed. All right, so let's take a look. What is the pivotal point? Well, the pivotal point is still that 0. The only problem is the height's going to be, or what's our input? The height's going to be 1 because we can see that that's where it should be 0. The only problem is this is raising the graph up 1. And I can graph that for you right now. So let me duplicate this, but have a graphing tool here. Let me see if I'm going to be able to move this. I hate how I can't move this tool. Is there a way for? I guess there is. It's going to be a little weird. 2v divided by 5 to the 1/3 power. 1/3 power. That's cubing it. And then here I do the plus 1. So I should make this an x to represent my input. The 1/3 power is the same thing as a cube root. So you can see here that the pivotal point is right here. The input of the volume is 0, but the height is 1. So what we're going to do here is our input was 1, but the height is 0. So we kind of have to think about that backwards. The volume is our input, and the height is 1. I think I've been saying that, but it really isn't viable. So it's not viable because how can you have something? You don't want something with a 0 volume, basically. All right, so now we're going to look at this function. So we can see this here. What's happening? Oh, I kind of already graphed it for us. We weren't supposed to look at it. I'm sorry. It should be at 0 and plus 1. But you see here, the pivotal point looks like it's more this plus 3. Definitely don't want that one. This one's a little better. This one's a squared, so that's definitely not it. This one, again, is a little better. It's at 1. So what we're going to do is look at our inputs to kind of figure out which one's which. So at 20, we should be at 3. So again, our options are pretty much stuck with a B and D. So at 20, 20 is too small. Let's do 160. Where should we be at 160? At 160, we should be at 5. 165, negative 160 should be negative 3. This has to be it. Perfect. And then just evaluate. So try to see what you might have struggled with. You can even, uh, for example, I would probably give myself like a 4.5 because I did end up using Desmos to kind of see it. Um, at least see the graph because I wasn't supposed to graph this. Scientific calculators make sense. You need it to blow through this a lot faster. But I was definitely not supposed to graph it to help me out here. I did still use facts on the chart to graph it, but I probably shouldn't have been doing that. So summary. So again, always watch these videos, guys. I know you're watching my videos, so you think you have it down, but I do recommend these because just hearing it from a different perspective helps out. It's helpful to always get something from a different perspective, just like it's always helpful to do those self evaluations and really ask yourself, what is it I didn't know? So I know this one was a short part 3, and I could have just tacked it on to part 2, but again, these videos are going to come out based on times of appointments and that I have with other students. So hopefully these videos are helping, guys. Leave a comment if there's anything you think I can do to make it a little bit better. Uh, and I'll see you guys on module 4.